Hi everyone, welcome to MPE EDU channel. I hope all you are keeping well. I'm sure you are still very focused on your study despite the inconvenience caused by COVID-19 pandemic. Due to this virus, all schools and colleges are closed. Don't worry. For your study and for helping your studies, we will bring online classes. Dear student, stay home, stay safe from coronavirus, and study well for your the next classes. This is our channel. Please subscribe our channel, like the videos, and share the videos as much as possible. This is Rama Avabrat, a chemistry lecturer. So I'm taking your second year theory classes, starting with the first topic. It is solid state. Okay. Dear student, the first thing is what is solids and how the particles are arranged in solid state. Before that, we already well known about there are three different states of matters: solid, liquid, gaseous. The gaseous state and liquid states are already studied in your first year, and solid state part is in your second year part. Solid state of a matter in which the constituent particles are arranged very closely. The constituent particles can be atoms, molecules, or ions. So the constituent particle, it may be atoms or molecules or ions. The solid particle, it may be made up of anything. The next is properties of a solid. Properties of a solids, it is you are already studied. This part is already studied in your SLCs. But just we recall what are the important properties are there. Okay, the first property of a solid, they have definite masses and volume and shape. Okay, the next thing is they are incompressible and rigid. So incompressible, so we can't convert into any other form. We already know about the compressibility nature of liquids and the solid gases. In case of a gases, when we compress the gases, it comes to liquid state. When we compress the liquid, it goes to solid state, but there is no further state to compress the solids. So it shows incompressible nature. And solids are rigid. Why solids are rigid? Rigidity of solid is based on the compact arrangement of atoms, and each and every atoms are vibrate about their mean position. Okay, the next point is intermolecular distance are short, and hence the intermolecular forces are strong. So we already studied about intermolecular forces in lower classes. Intermolecular force is a force of attraction between the molecules or in particles. So the intermolecular distance between the particle is very less. Due to that, the why it is less? Because particles are closely arranged. So therefore the force of attraction between the particle become more, therefore intermolecular force is strong. The next thing is their constituent particles have fixed position and can only oscillate about their mean position. So these things already studied. Okay, the next thing is, so these are the important properties of solids. Okay, next is the very important aspect of your solid state is classification of the solid particles. Solid state or solid particles are classified by considering different criteria. The first criteria is based on the arrangement of the particles. So based on the arrangement of the particles, solids are classified into two types. One is crystalline solids. Okay, the first classification is crystalline solids. Crystalline solids means the particles are orderly arranged and there is a definite shape. And the second type of solids is amorphous solid. Amorphous solid in which particles are disorderly arranged. Just we observe some examples of crystalline solids. The example for crystalline solids are iron, copper, diamond, and etc. Okay, next amorphous solid, glass, plastic, rubber, better to be called as all polymeric substances or polymers are amorphous solids. So in that cases, the particles are irregularly arranged. So in these cases, we can see the missile badges of particle. Okay, so but in case of crystalline, the particles are orderly arranged. Okay, next we move on to some crystalline solids. Just you can see the crystalline solids, and crystalline solids are solids in which particles are orderly arranged and they have definite characteristic of geometric shape. The examples are diamond, quartz. Okay, the next graphite is also example. We are already studied the structure and the geometry of diamonds and graphites in our first year classes. What is the hybridization and what is the geometry and all that. So these are crystalline solids. They have definite geometry and have definite shape. Okay. Next is the very important thing is difference between crystalline and amorphous solids. So these are the two types of solids and they have some important differences. The first thing is crystalline solids. Crystalline, they have definite characteristic of geometrical shape, and amorphous, they have irregular shape. So shape is not regular. You can see in the diagram the particles are orderly arranged. So one is the pink sphere or pink particle, pink particle, pink particle. Okay, next the green spheres, they are orderly arranged. These all particles are orderly arranged. I can see in this column, so all the column, all are same particles. These are same particles, so there is no mixing of any different particles. They have definite and regular arrangement. But in case of amorphous, what happens? So they are irregularly arranged. So one after another, there is a different particles. We can see. Suppose you consider in this column, we can't observe any same type of particles. Green, the next is pink, green, pink, green. Okay, different particles. Suppose you are going through this column, pink, 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 green, green, like that. So they have irregular arrangement of particles. So that is the first difference between the crystalline and amorphous. The next difference is they have long range order and amorphous is short range order. So what is the meaning of the long range order? In the diagram, throughout the crystalline solid, from this point to this point, we see the same order of particles. Particles are orderly arranged throughout the crystal. In any small portion also, we can't see any irregular arrangement. Therefore, it is called a long range order. Order is long. And in case of amorphous solid, we can't see any order arrangement of particles. Suppose we are going through this line, so we can see the different types of particles, irregularity, and in a small range only. So the green after another sphere is a green only. In a small range only we observe the order. Therefore, they are irregularly arranged and they have short range order. Okay, the next thing is the third point or third difference between the crystalline and amorphous is they have sharp melting point. They have sharp melting point. It is very important point. Okay, but in case of amorphous, they are gradually softening over a range of temperature. That means there is no definite heat of fusion or there is no particular melting point. There is a range of temperature. So that is the important point of crystalline. Come to the fourth point of difference between crystalline and amorphous. The very important concept in the difference is crystalline solids are anisotropic in nature. So, and amorphous solids are isotropic in nature. Then, what is the meaning of anisotropic and isotropic in nature? The anisotropy nature, there is a physical properties shows different value when we measured along different direction in the same crystal. And isotropy means some or few physical properties of the crystal is same in all direction. Then how can we measure it? In this diagram it clears that when we measure some physical properties like refractive index, mainly refractive index and conductivity, when we measure the refractive index of any crystalline solid, then it gives different value in different direction. How it is and why? In case of a crystalline solid, particles are orderly arranged. Therefore, when a beam of light is passed through in any one direction, for example this one A, when a beam of light is passed in this direction, it passes only pink colored particle or one type of a particle, and the same beam of light is passed in another direction like this one B, then it passes through green particle, pink particle, green particle, pink, green, like that. So it passes at different particles. Because of that, the reflection of the light is changed. What is refractive index? It is sin I by sin R. Okay, so angle of incident, angle of reflection changed. Due to that, refractive index value is changed. Therefore, one physical property, that one refractive index change in case of crystalline solid. This one is crystalline solid. It shows different physical property in different direction. Due to that, this type of nature in the solid is known as anisotropic nature or anisotropy in a crystal. Okay, similarly conductivity is also different in different direction. But what happens in case of amorphous solid? Okay, in case of amorphous solid, how particles are arranged? Yes, particles are randomly or disorderly arranged. So due to that, accidentally the physical property like refractive index and conductivity becomes same in all direction. It passes as same number of particles or same type of particle in all direction. It happens accidentally. Okay, just observe in this diagram, when a ray of light is passed in this direction, it passes pink, the next is green, pink, okay, green, like that. Okay, suppose it is passed through in another direction, same similarly it become pink, green, pink, like that. So accidentally it happens in all direction, it gives the same value of physical properties. Due to that, this type of nature is called isotropic. Amorphous crystals are isotropic in nature. Iso means same physical values or same physical properties values like refractive index and conductivity. But in case of a crystalline solid, it differ. Therefore, it is an isotropy. Okay, for example, it is we can easily observe in case of a glass. When a torch or a beam of light is passed one side of the glass slab or top of the glass slab and bottom of the glass slab, it gives the same deviation of a light. That means a refractive index becomes same. So due to that, it is isotropy. Glass is example of amorphous solid. So amorphous solid shows isotropic nature. Okay, next we move on to the another difference. The fifth difference is crystalline solid have definite and characteristic heat of fusion. Heat of fusion or latent heat of fusion. Heat of fusion means it is a amount of energy required or convert solid to liquid. So conversion of solid to liquid means the process is melting of solid take place. We already know that in the third difference, it says that sharp melting point. Crystalline solid has sharp melting point. The melting point is sharp. That means particular temperature it melts. So therefore, it is a definite value of melting point. Therefore, the heat of fusion also definite. Heat of fusion is conversion of 1 mole of a solid into liquid. So amount of heat required. Amount of heat required is definite because melting point is definite. Therefore, heat of fusion also definite. So there is nothing in difficulties there in this part, I think. Okay, the amorphous is do not have definite heat of fusion. Okay, next, the next point is they are called true solids. Crystalline solids are known as true solid and amorphous solids are known as pseudo solid, or it is called supercooled liquid. Supercooled liquid. That means amorphous solid shows some liquid properties, does not shows complete solid properties, but crystalline solid fulfills all the solid properties. Just you can see in this case, in a glass case, uh, the old glass slab, it become thicker in the bottom part and thin at the top because uh, day after day slowly the movement of a glass particle take place. Suppose glass is present in a standing position, then the molecules of the glasses comes down, and because of that bottom part of the glass become thicker. Okay, so it is observed in case of buses or any automobiles, like that is a glass window glasses. Okay, so we can observe the example in that cases that indicates the little bit movement of the glass molecule. Fluidity, the fluidity observed. Fluidity is a property of liquid and gases. So amorphous solid shows few gases and liquid property. That means it is not a true solid, it is pseudo solid, or better to call it as a supercooled liquid. Okay, so these are the few very important differences between crystalline and amorphous for your theory part. This difference is or distinguish between crystalline and amorphous is very important for your annual exams. Okay, it is very important for 2 marks. Okay, it may be asked for 2 marks. 2 marks means only 2 points are enough, but you should know more than 2 points. Okay, minimum 4 points are required. Okay, thank you. Next we are going to the another part of the solid state. Okay, it completes the classification of solids. Next we going to study about only crystalline solids. Only crystalline solids. What are the classification of crystalline solids? The crystalline solids are classified into four types based on the nature of the molecules or the particles present in the solid. Okay, the particles based on the particle present in the solid or crystalline. The crystalline solids are classified into four types. Okay, what are they? First one is molecule, second one is metallic crystalline solid, next is atomic. Okay, just it is atomic. Atomics are different types, covalent and metallic. Next, the last one is ionic. Okay, so these are the different types of crystalline solid. The first thing is molecular solid. Okay, molecular solid in which particles are molecule and molecules shows intermolecular force of attraction. Therefore, the type of force between the particle is, it may be dispersion or London force, dipole, hydrogen bonding. So these three types of forces are observed. And what is the physical behavior of the molecular solid? They are soft in nature, low moderate melting point. Melting point is little bit lower, and poor thermal and electrical conductivity. There is no free ions or free electrons, therefore conductivity is poor. Okay, the next example for molecular solid, the molecules, the solid O2, solid phosphorus P4, solid H2O, ice is example, sucrose is example for molecular solid. Okay, next we move on to the second type of crystalline solid, that one is atomic crystalline solid. Atomic crystalline solids are further classified into metallic and covalent. Okay, why it is further classified into two? Because of the nature of the atom. Some atoms are metallic in nature, for example iron, copper, sodium, or in the part of periodic table. Okay, the left part of the periodic tables are metallic nature, and the extreme right part of the periodic tables are non-metallic atoms. Suppose the atomic solid is made up of metallic like sodium, copper, iron, like that, then become metallic solid, a crystalline solid. And suppose it is made up of a non-metallic atom, then it become a covalent. Covalents are further classified into three types: network covalent, simple covalent, and the polar, and like that. Okay, the first thing is metallic crystalline solid. The particles are metallic atoms. And what type of bond is observed? Yes, exactly, it is metallic bond. And it is soft compared to network covalent, but it is hard compared to molecular solid. And a little bit changes observed when we move from left part of periodic table to right side, then the nature changes soft to hard. Next, low melting point, and after that it become very high. Suppose it hard, shows very high melting point. Next, it shows metallic property like malleability and ductility, and it conduct electricity. Okay, so example is metallic atoms like sodium, copper, iron. Okay, the next classification is covalent crystalline solid, in which the particles are non-metallic atoms, and type of bond is covalent because of the non-metallic nature. And they shows hard and high melting point, poor electric conductivity. Okay, the network covalent compounds or crystallines are very hard compared to other all crystalline solid. Example is diamond. Okay, quartz and diamonds are the example of network covalent compounds. And few like graphite, it is soft, it is a simple covalent compound, it is not a network covalent compounds. It is also example for covalent crystalline solid, graphite. Okay, the next is ionic crystalline solid. The last type of crystalline solid is ionic crystalline solid, in which particles are uh, cations and anions, positive and negative charge ions are there. Because of polar nature, positive and negative ions, it shows polarity. Due to that, ionic inter-ionic attraction is observed. So it is, that is the type of force observed, or electrostatic force of attraction, what you call this ionic interaction. And next is these are hard compared to molecular and metallic solids. Okay, but they are soft compared to network covalent, only network covalent compounds, and shows high melting point. Okay, and good thermal and the electric conductivity. Okay, example is ionic solids. Example is sodium chloride, calcium fluorides, and magnesium oxide, and whatever you are studied in your lab. So what are the salts you are studied? These all are ionic in nature. Okay, so these are the examples. So this is the brief explanation about the classification of crystalline solids. Okay, these are the crystalline solids. Next, we move on to the classification of molecular solids. Okay, molecular solids are further classified based on the type of force exist between the molecules. The molecular solids are classified into three types. One is polar molecular solid, non-polar molecular solid, hydrogen bonded molecular solid. Okay, first type is polar molecular solid. Polar molecular solids are or shows a attractive force. What type of attractive force is observed? It is dipole interaction. Because of polar nature, molecule is polar. Example is HCl. So solid HCl is a example of molecular solid. In case of HCl, what happens in case of HCl? H plus and H is exist in plus in the form of H plus, and Cl exists in the form of Cl minus. So H plus shows partial positive charge, Cl minus shows partial negative charge. Due to that, polarity arises. Due to this polarity, these shows dipole interaction. So what is dipole interaction? It is a intermolecular force between the two polar molecules. Okay, therefore these are polar solids. So dipole interaction is observed. They are insulators, and the physical nature is soft, and melting point is low. So HCl is and HCl, HBr, so mainly these are liquid or gaseous state. So that means melting point is very low. In ordinary temperature, they exist in liquid or gaseous state. Example is solid HCl, solid HBr. Okay, the next thing is non-polar molecular solid. Non-polar molecular solid means molecules are non-polar. Non-polar molecular solid shows dispersion or London force. The dispersion or London force definition itself says the force, intermolecular force, exists in between the non-polar molecules or neutral molecules. So interactive force or bonding is London force. Next, they are insulator, they are very soft, and melting point is also very low. And example is solid argon, solid CCl4 carbon tetrachloride, solid H2, solid I2, or solid diatomic molecules like O2, I2, CO2. Okay, so these are the example of non-polar molecular solid. The last type of molecular solid is hydrogen bonded molecular solid. Hydrogen bonded molecular solid, it is a special part of polar molecular solid. If the bonding or attractive force is more, dipole interaction is become more. When it become more, in case of molecules contains more electronegative atoms like fluorine, oxygen and nitrogens. So these are the highly electronegative atoms. When the molecules contain such type of atoms, then it shows hydrogen bonding or strong dipole interaction that convert into hydrogen bonding. So hydrogen, that type of molecule is known as hydrogen bonded molecular crystalline solid. They are insulator, hard in nature, very hard compared to other, because force of attraction is strong. Therefore the nature become hard, and melting point and boiling point is low. And example is the molecules made up of atom are more electronegative like oxygen, nitrogen, fluorine. Therefore the examples are ice, solid water, ice, and solid ammonia are the example. Okay, so this classification is important for your exam point of view. Polar molecular solid, non-polar, hydrogen bonding, these three are the different types of molecular solid. So this is a classification based on the different type of force exist between the molecular solid. Okay, so these are the classification of crystalline solid. Okay, so just observe some structure of crystalline solid. Okay, the molecular crystalline solid, so it is a molecular crystalline, one molecule, it's another molecule. So between the molecules there is an intermolecular force of attraction is observed. And then covalent molecules, particles compactly arranged compared to molecular. So next ionic, it's a structure of sodium chloride. Okay, next metallic, so particles are very closely arranged, therefore most of the metallic solids are very hard. Ionic solids are also hard, but molecular solids are soft because intermolecular force of attraction, that one is called van der Waals force. Next, okay, next part will be discussed in the next video. Thank you for watching this video.